Lesson 10 is titled Writing Division Answers as Mixed Numbers and then Improper Fractions. Now, I feel like I already told you that we're going to do them as fractions, but now I'm not remembering if it was your class. So we're going to go ahead and skip the warm-up, or hope maybe you already did. I put a little note there. Anyway, I'm going to skip that again. You do that on your own. That's fun. That's warm-up, okay? And it's optional. Now we're going to jump to example 1. I don't know why I had that there. I kind of wish I hadn't. What percent of the circle is shaded? Okay, so it looks like we have 1/3 shaded. Do you agree with that? So if we have 1/3 shaded and we're dealing with percents, what you need to know is if the whole thing was shaded, it would be 100%. Okay, so if 1/3 of 100% of it is shaded, we're going to say 100% divided by 3. Okay, so let's go ahead and do that. Now it's not going to give us a nice perfect number because 3 does not go into 100. So we're going to leave it as an improper fraction percent. Okay, so and that's just because how the book likes to do it. So we're going to kind of keep it with that because you're going to have time tests, math facts where they want 1/3 to be written as a fraction rather than decimals. Okay, so I'm going to go ahead and do long division. Okay, 3 times 3 is 9. Subtract, bring down the 10. Oh, look at that. It seems to me there's going to be a pattern, right? If I brought down another 0, it's just going to go on and on. So what we have is 33 remainder 1, but we're not going to write remainder 1 anymore. We're going to say 33 and 1/3%. Okay, this is your numerator and this is your denominator. Okay, when you do your remainders, they should be fractions now. Okay, so for example, on number 2, it says convert these improper fractions. And I always like to say improper fractions are like when the dad is on the kid's shoulders. This just feels improper, too heavy on top. The little kid is trying to hold dad up and it's not working. It needs to come off. Okay, so what we're going to do is the book does it different. I guess they did 2 different ways. No, 1 way. Again, I don't like to do it this way. I think of it, either do it in your head or think of it, it's the same as 5 divided by 3 because all fractions are division problems, right? So 5 divided by 3. 3 goes into 5 once, okay, with 2 left over. So again, that's your numerator, that's your denominator. So your final answer is 1 2/3. Okay. Now, once you've gotten really good at this, some of you in past books maybe have done this already and already know that, well, I know that 3 goes into 5 one time with 2 left over. One time with 2 left over. So you can, and I would encourage you to start to be able to do these mentally without having to do the long division, okay? But I want you to know why the long division works, because every fraction is a division problem. Okay, so now we have 6/3 and make that that's an improper fraction. So you go, oh, how many times does 3 go into 6? Well, perfectly 2 times. So the answer to that, if we simplify it or convert it, it's 2, because 6 divided by 3 is 2. All right, with no leftovers, so it's just a whole number. All right, so now how do we go the other way? If we have the mixed number and we want to make it improper, okay? The way I do that is I always start on the bottom and go clockwise. I take the bottom, multiply it by the whole number, so we multiply here, okay? And then we add when you get to the 7, okay? 5 times 3 plus 7. 5 times 3 plus 7. Okay, so what that is 5 times 3 is 15 plus 7 is 22. Okay, so we get the number 22. Now where's the rest of my fraction? Well, the bottom never changed. Do you notice this up here? You keep the same denominator because that's what we're dealing with. Thirds. Here we're dealing with fifths. So that's the same as 22 fifths. Okay? I'm looking just to see what the book does it any different than I do. Yeah, they do the long way, which I don't quite enjoy. So I'd rather you do my circle. 5 times 3 plus 7. You're going to get a lot of chances to work with that. So there it is. There's your first one. All right, example 4. We are simplifying some fractions. So this is, should be pretty review. Okay, so again, same denominator, so we're allowed to add them. And they keep the same denominator. And we have 8 fifths. Now, I think they wanted us to simplify that, so for now in this book, they don't want to leave things improper. As we go later on in math, in the next few years, we get to leave improper fractions. We get to be done when it's at this point, but not today, not this, probably most of this year. So we have to change that into a mixed number. Now, can you do that in your head yet? How many times does 5 go into 8 perfectly? Oh, only one time, right? And how many fifths are left over? Well, 5 times 5 is 5, so 8 minus 5 is 3. Okay? Now, if that was difficult for you, remember you can always go and do 8 divided by 5. Okay? And see how I got that. Okay? 1 and 3 fifths. Okay? So, letter B. We have multiplication here. So that means we multiply straight across, okay? So we get 15 eighths. Now, again, top heavy, so that's an improper. So we're going to make it proper. How many times does 8 go into 15 perfectly? Well, 8 times 2 is 16, so it only goes into 15 one whole time. And then there were 7 is your remainder. So we have 7 eighths. Okay? This one is a mixed number. So we can go ahead, not a mixed number plus a mixed number. So we can go ahead and add the whole numbers because we can. And then we can add, we're going to have fifths, 6 fifths. Okay, so this is top heavy. We don't like that. We want to get that fixed. So don't worry about the 2. How many times does, so I can even just tell you, we could, 6 fifths can be changed to 1 and 1/5 because 5 goes into 6 one time with 1 left over. And then we have the 2. So I'm going to add those together. We have 3 and 1/5 is your answer. Okay, and there we go. And the book has all these if you need to see it a different way. All right, example 5. Write each mixed number as an improper fraction. Okay, so to practice that again, we start on the bottom, multiply, add. Okay, 3 times 3 is 9, plus 1 is 10. So 10 thirds. Okay, why don't you try the other 2? Go ahead and pause me and then try them and see how you do. Okay, and now you should be unpausing, and we have 4 times 2 is 8, plus 3 is 11 fourths. You can see that. Okay. 2 times 12 is 24, plus 1 is 25 halves. Okay. All right, now we have practice. You can pause me and we can go through, you can go through this, and or just pause me, go for it, check your answers in the solution manual after you're done doing it, or so just turn it off and just go for this, or pause it and I'll work through these, but you don't have to watch all of it if you got them right, okay? So you may be done now or pause. Okay. All right, so Logan cut a 35-inch rope into 4 equal lengths. So what that is 35 fourths, or 35 divided by 4. Okay, how long is each piece? How many times does, I'm going to do this one in my head, 35, or 4 goes into 32 times, sorry, 4 goes into 32 8 times, okay, with 3 left over. and we're dealing with inches. So hopefully you guys either wrote IN or inches. Story problems always need that label. Okay. 1 day is what percent of 1 week? 1 day is what percent of 1 week? Okay, we'll think of it this way. 100% is a week, and there are 7 parts. So 100 divided by 7. Okay, so 7 and 4. Okay, now we have 14, remainder 2. So we're going to say 14 and 2/7%. Okay. All right, this one, convert each fraction to either a whole number or a mixed number. Okay, 12/5 is going to be 2 and 2/5. This is going to be 2. Okay, this is 12 and 12/7. So, in the book it says 2 and 2/7. I wrote it wrong, differently. So, all right, so 12/7. I'm going to go ahead and change 12/7 and make that equal to 1 and 5/7. And then I'm going to add it to that 12. So we have 13 and 5/7. Okay. Draw and shade circles to illustrate that 2 and 1/4 is the same as 9/4. Okay, so here's how we do that. Here's a hole, and then here's my 4th. Okay, so here is my drawing of 2 and 1/4. Okay, and then I'm going to draw 9/4. So here I have 4/4. Here I have 8/4, but I still don't have enough. So I've got 8 shaded in, right? So in order to get 9/4 shaded, I have to make another circle and shade part of that. Okay, so now you see here, those are equal. So the book, as you do that for problems, and it looks like this. This is what your picture looks like. 2 holes, a 4th, is the same as 4/4, 8/4, 9/4. Okay? All right, this one, 2/4, 6/3. You can go ahead and write it and then simplify. Okay, multiply straight across. So we have 14/9, and 9 goes into 14 one time with 5 left over. It's a 5. Okay, this one would be 2 and 4/3, and that turns into, the 4 can get off the 3. 3 goes into 4 one time with 1 left over, so it would be 1 and 1/3, right? 1 and 1/3. So we get 3 and 1/3 is your answer. All right, converting to improper fractions. All right, 3 times 1 is plus 2 is 5/3. I'm going to power through these quick. 6 times 3, 18, plus 5 is 23, right? 18 plus 5, yes. 16 plus 3 is 19. 4ths. 10, 11 halves. Okay. 24, 27 fourths, and 52 fifths. All right, give yourself a hand if you got all those same answers, okay? These should be fun. Was that enjoyable? I hope so. All right, so that's it for your lesson 10. And for those of you coming back to school with me on the 15th, this is all you have to have done. All of these, you're going to turn in all your notes, all your lesson problems, all your practice problems. Actually, I believe they're all on your notes. And bring your book to class. And I will show you how we're going to keep track of those math facts. Okay, so yes, you need to bring all this stuff back for me so I can check it off. And then I will talk to you at school how we do the math facts. All right, good job.